All right, we are moving on to another conic section. We are now looking at equations and graphs of ellipses. So here I've sketched two examples, one that has a horizontal major axis and one that has a vertical major axis. So the equation for an ellipse is x minus h squared plus y minus k squared, so it's similar to a circle, but now we're dividing by a squared, b squared, and it equals 1. They will always be equal to 1. And then the difference over here, so I've got x minus h squared over b squared plus y minus k squared over a squared equals 1. So what I have up here is that the a value is always the bigger value between the two denominators. So if a is larger and it's under the x, that makes sense. That would create the horizontal major axis. But when the larger number is under the y, that's what creates the vertical major axis. All right, these both have a center, and you could probably guess what they will be. It is HK for both of these. So notice how we have vertices and co-vertices. So vertices will be the ends that are on the major axis. So for this one, the vertices will be your h plus or minus a coming from here, k. And then the major axis is a horizontal line, so it's y equals, and it's y equals k. All right, so now let's look at co-vertices. So co-vertices would be kind of like those endpoints on the smaller axis, the minor axis. So co-vertices will be h and then k plus and minus b. And the minor axis is a vertical line, so it's at x equals h. All right, and now every ellipse has foci. Sometimes it's pronounced foci. And they are somewhere in this location, always on the major axis. And we're going to, there is a c value that we will have to calculate to help us find how far away the foci is from the center. So to calculate that c value, we do c squared equals a squared minus b squared. All right, so similar over here, except this time the vertices will be top and bottom, and the major axis will be that vertical line. So the major axis is now x equals h, and then those vertices are now h, k plus and minus a. And then the co-vertices and the minor axis will be going this way. So that minor axis is a horizontal line, y equals k. And then the co-vertices are h plus or minus b, comma k. And then the foci we will also use, so it's on the major axis. We'll find c using the exact same formula, that c squared equals a squared minus b squared. And when we're doing this, just remember a is always the larger number. So a is always that distance from the center to a vertex, and then b is always the distance from the center to a co-vertex. And before doing some specific examples, a fun fact: if I pick any point on the ellipse the distance to the foci. So this distance and this distance, if we call this distance 1 and this distance 2, distance 1 plus distance 2 will equal 2a. Well, what is 2a? A is the distance from the center to the vertex, so 2a would be all the way across. And that is true for every point on an ellipse. All right, so now let's practice graphing one. I know the last slide was a lot of information, but they're actually very easy to graph. So let's start with the center is at the point 3, -1. All right, so now, without even thinking of A and B, let's just look at underneath the x. Well, x is always your left and your right. And then it's the square root of that, which is 6. So from the center, I'm going to go right 6. And that is a vertex. And go left 6. So those are my two vertices that lie on the major axis. And the number under y, so y's are up and down. So square root of 9 is 3. So from the center, up 3 and down 3. And then you can just sketch it to your best abilities. And then if we're going to graph the foci, we need to do our little formula. So c squared equals a squared minus b squared. A has to be, so here's where we get our a and our b, and a comes from the larger number. So c squared equals a squared is 36 and b squared is 9. So c squared equals 27. So c is plus and minus the square root of 27, which is about 5.2. So what that means is if we start at the center, on the major axis, we're going to go right and left 5.2. So we can just kind of estimate, it's pretty close to the vertices here. And there we have the full graph of an ellipse. All right, let's do one more. This one will have a vertical major axis. So let's see, the center is -2, 4. And then under the x, so that's our left and right, we're going to go 4. And then under the y, we'll go up and down 5. So you can do your quick sketch, and then c squared equals, a is the larger one, so 25 minus 16. So then c equals plus and minus the square root of 9, which is 3. So on the major axis, so this time the major axis is up or down, you can put your foci. So there we go. They're pretty easy. But now, one more example where it is not in the conic form. It's not in that standard form of an ellipse, and we have to convert it to that form. All right, so we've done this with parabolas and circles. So let's start by grouping our x's together, grouping our y's together, getting that constant over. So 4x squared minus 24x, leave space to complete the square, plus y squared plus 4y, leave space to complete that square, and we've got a -24 on the other side. All right, so completing the square, I need to first take out a 4. And then we can do our b over 2 squared. All right, so -6 divided by 2 squared is plus 9. And then we have to balance it out. So if I put a plus 9 here on the other side, I need to not plus 9, but plus 36. And then let's see, over here we've got 4 divided by 2 squared, which is 4. Balance it out, plus 4 on the other side. All right, so now let's factor. I still have the 4 out in front. This will go down to x minus 3 squared. Plus, this will factor down to y plus 2 squared. Equals, let's see, on the other side, equals 16. Now, if you remember, in the equation for an ellipse, they're always equal to 1. So, I want to divide this constant here by 16, but that means I need to divide everything by 16. And then I can simplify where I need to. So x minus 3 squared over 4 plus y plus 2 squared over 16 equals 1. So here it is now in the correct form to graph. Let's see, we have a center at 3, negative 2. And then let's see, under the x is a 4, so I'm going to go left and right 2. And under the y is a 16, so I'm going to go up and down 4. And there I can sketch. And to find the foci, c squared equals 16 minus 4. So c equals plus and minus square root of 12, which is about 3.5. So on the major axis, 1, 2, 3.5. Pretty close to the vertices there and there. So there is your full lesson on graphing ellipses. Good luck with your lesson.